Hello, my name is Michael Bradley and I'm with a new planning center, and in this video we're going to talk about how to make great STL files. So let's jump right into this. On this STL file we can see that we have upper and lower in occlusion. Let's go ahead and get rid of one of these models. We can see that we have a full arch, which is great because we're going to design the surgical guide to place on top of the STL file. So we can see this here. This is the surgical guide. Now we want to make sure that we have sufficient gingiva to create the guide. As you can see that the guide, we would like to follow the contours of the gingiva. Now if we don't have that gingiva scanned on the STL file, then we're not able to create the guide, obviously, to place it all the way to the zenith of each tooth and to cover all the teeth. So we want to make sure that we have sufficient gingiva. I would say at least a minimum of 2 millimeters of gingiva, let's say in one of these smaller areas here. So even more than this, it's about 1.64 millimeters of gingiva. So I would say this is the minimum of what we want, but this still works. But just so you can understand why we want a good amount of gingiva is so that we can get the surgical guide and create it to make it nice and sturdy and accurate. Okay. Now, one thing that you want to look out for when you're scanning is watch out for excessive amounts of saliva or bubbles, because if those are on the scan, let's see if there's a little bit here, you can see maybe a little bit of saliva or bubbles there. This is actually a pretty good scan, that's why we're using it. If you have an excessive amount of bubbles or saliva, that's going to be part of the model, which in turn is going to be part of the surgical guide, which we don't want because then it's not accurately fitting to the teeth. So make sure that the teeth are properly dried. Along with that, we want to get a full arch of top and bottom. Now, one of the reasons why we want to do that is so that we can get the teeth in occlusion on the model. So as you can see, we're in occlusion here. Now, often when you're scanning a patient, we see that they've only scanned one side of occlusion. Now, what happens with that is that, let's say this side on the right of the patient is in occlusion, but then the lower model is angled, and then on the other side on the left, it's out of occlusion. So make sure you scan the occlusion on both the right and the left in order to make sure you get both sides and everything's nice and even. So that being said, I'll show you one of the reasons why we want a good STL file. Here is the CBCT that is nicely aligned with the STL file because, again, going back to the STL file, we have such a nice scan of all the cusps of the teeth, and this is a good STL or CBCT file, so we're able to align those properly. Now, if the CBCT file and the STL file are not able to be properly aligned, that's where it gets very dangerous, because let's say we're placing the implant in the bone, but this STL file is not in alignment with the bone, and we create the surgical guide to go on the STL file, then we're placing the guide to guide the implant that is not going into where we want because it's not in alignment with the bone. So critical to make sure that you have a good STL file that can be aligned properly with a good CBCT so that we don't run into any problems with the guided surgery. So that being said, let's show you a couple examples of not great STL files. Now here is one that is just a partial STL file. So you can see we got just half of the maxilla, not even half. One of the reasons why we don't like to work on these is because the software has a very hard time aligning this file with the CBCT because it doesn't have enough points of reference to align like you would on a full arch. So we definitely recommend, if whenever possible, get the full arch so that we can align it properly with the CBCT to make sure your guided surgery is happening the way that you want it to happen. Along with that, you can see a lot of artifacts here. We got a lot of different layers on the cheek, which isn't horrible. We can trim those off. Get a little bit more on the teeth here. This isn't great because obviously that's not part of the tooth. And that's going to be on the guide when we design the guide off of the STL file. I'll show you a different example here. Here's an upper model. If I can pull it up here. We got a lot of artifacts here. You can see big chunks of whatever that is, maybe the person's lip or something. And that's going to throw off our guide. And it's also may throw off our planning because we're not sure exactly where the tooth is or the occlusal surface is maybe. We also have down here, we have some holes in the model as well, which is not going to be able to be based, which is not going to be able to be printed. So we want to make sure that it's free of holes, free of artifacts, free of double takes. You can see on this model that there's a little bit of a question as to whether or not these are fitting properly. The scan is kind of overlapped, so we're not really sure where the teeth are. And so perhaps even this guide wouldn't fit on the actual teeth because we're creating it off of a model that is not accurate to the teeth. So all things being said, I'll bring these models back. We want to get a full arch of top and bottom, a good amount of gingiva free of saliva and bubbles, in occlusion on both sides, and that will make everything much smoother and surgery much safer.